And what else do we have on this tablet here, some of the other demonstrations?
One of the things we have is we actually have the camera embedded here in the tablet. So as I said earlier, we took the existing camera that was in there out, we cut the whole square, and then put our camera in. It directly interfaces through the standard interface for cameras and cell phones directly into the processor. So I can show you some of the things we can do with this system. So here is the image as we captured. It's an all-in-focus image. You can see everyone's in focus from near to far. One of the things we can do here is we can move the focus.
Does it recognize a face and focus on a face, or does that not matter?
No, it doesn't matter at all, because what we're doing is we have a depth point for everything in the scene. So at this level, we're saying uniformly, the way a normal lens would do this, here is where the depth range is. Right? But what we could do is we could structure it so that one person is in focus and the person next to them isn't. I don't have this image here, but we're also doing this non-destructively. So we can move the focus from point to point. But one of the things we can do in this that you can't do in a normal camera is the person in the foreground's in focus and the person in the background is in focus, but the person in the middle is out of focus. So imagine you're on vacation in Paris, and you stand by the Eiffel Tower and you take a picture of your spouse. And you've got the beautiful Eiffel Tower in the background, you've got your beautiful spouse in the foreground, and 200 sweaty tourists between. So you can actually have now an image where your spouse is in focus, and the Eiffel Tower is in focus, and everyone else is out of focus.
And I understand that you can also cut people out of the picture and put them into other pictures.
Right. So
as we saw in that very first video.
One of the things we can enable is, let's say this image was posted, she posted this image in Facebook, and the other two gentlemen here are tagged in it. So one of the things we can enable is, because we have a depth map that's of the same resolution as the image itself, we have very, very finely defined edges. And so let's say this image got posted and the gentleman at the top says, you know, I really don't like that other guy. Well, he can get rid of them and repost the image this way. Now, perhaps she sees this and is a little freaked out. Well, she can go and, just for fun, apply a little artistic.
It's a lot simpler than Photoshop, I would say.
Yes, and what we're talking about is being able to do this with your fingers on your phone. I mean, people have, you know, the digital shoebox full of images that they'll get to someday to fix. If you could fix it as soon as you captured it, and it was easy, you didn't have to read the 300-page Photoshop manual, you're going to see a lot of people much happier with their images. But also what this enables is a serialized editing of images. Right now, when you capture an image and you send it up to Facebook, what's the result? Maybe somebody hits the like button, maybe they write the equivalent of a Twitter comment. Oh, I like that image, right? Or I remember we were there. Now you can manipulate it. You can say, wait, I'm in the background. I want to pull myself into the foreground. Or I want to push that guy out into the background and behind somebody and repost it. You can add objects and they will scale correctly in the scene itself. And you can create this much richer social engagement with the images you post.
You're also inventing images too. This would be great for propagandists.
Potentially, yeah. I mean, you know, you remember back, you know, in a movie you saw Tom Hanks pretty much shake every president's...
like in the Soviet Union, somebody would be excised from the picture who was not in favor anymore. You could do that.
Yes, yes.
Well, how does this compare to a regular camera? Does this replace a traditional camera, or does the traditional camera still do some things that you want to keep?
It depends on the market. It depends on the product line. So, you know, the Pelican solution is very focused for the consumer space on small form factor cameras. So we're talking about cell phones and tablets and laptops and TVs, phablets, these kinds of opportunities. I don't see this having a lot of play in, say, a DSLR space, because in a DSLR space, you go and you spend maybe $1,000 for your camera, and you put it in the bag that has $30,000 worth of lenses. Well, because our lenses are very different, that's a proposition I don't see in the short term being one that's adopted. As it goes on over time, I see this as potential to support DSLR, because now you can have all of this depth information and align it with the DSLR image. But that I see as a little staged a little farther out. Right now we're focused very much on the consumer space and the implementations in the consumer space.
Now, is the camera actually available, or is it not quite on the market yet?
It's not quite on the market yet. What we expect is we expect this to, depending upon the customer, because this is going into existing well-known brand platforms, based on when they bring things to market, we expect this to be late next year or early 2015.
So if you buy an iPhone in 2015, it'll have this pre-installed instead of the current camera?
If you buy a phone, I don't want to pay
a
particular phone, but you know, there is a
smartphone.
We're targeting the smartphone because of the processing power on the smartphone. But yeah, there's a strong possibility that this will be in several different platforms.
In terms of price, is this a lot more expensive than a traditional camera? It sounds simple, complicated to design, but simple in function.
Yeah, it's right now it's a little more expensive because it's a much smaller base of suppliers. You know, the Pelican is a software company. We're working with the existing high-volume suppliers to make the particular chip and the optics. And these are companies that are shipping millions and millions of units a month, and they have the strong expertise and the capabilities on that side. And we have a very small number of suppliers right now. And as that supplier base grows, we expect there's going to be stronger price competition.
But it's basically software in that once you have these 16 images that are just slightly off because of parallax, then you can choose how you process them through the software.
Right.
Okay. So are there any additional functions that you can add to this beyond what you're doing now? And where do you see this technology going?
Well, a couple of the things. The way we have the architecture designed, each of the cameras is individually controllable. And so what this means is, right now, if you have a high dynamic range capture on a smartphone, what happens is it takes a long exposure, and then the next frame is a short exposure. And then it combines them. But the issue is, this is two separate points in time that it does this. And I've actually seen from some very popular smartphones, people having 8 eyelashes because they blinked between the two captures. And you have these kinds of issues with this. With the Pelican approach, we can have some of the subarrays with a long exposure. And within that exposure, the other subarrays have a short exposure. So we combine the data all within a single capture time to give you a significantly reduced motion artifact issue. The other thing we can do is we can have each of the cameras operating independently. So if
each of the cameras, each of the 16
each of the subarrays in the solution can be operating independently. So if I want to capture a high-speed image, high-speed video for slow motion playback, let's say 200 frames per second. If I want to do that, then that means the maximum amount of time I can have one frame running in a legacy camera is 5 milliseconds, as opposed to 30 milliseconds, which is normal. So that means it's 6 times less light per frame. With the Pelican solution, we can have one frame start with a 30 millisecond exposure, and the next frame 5 milliseconds later starts, and the next frame 5 milliseconds later, and the next one 5 milliseconds later, so that we can capture under the normal lighting conditions, because most high-speed imagery needs a lot of light. And so where do I see this being used? Well, for on your phone, you're at Little League game, your son or daughter's up at bat, the pitcher starts to throw the ball, you hit the high-speed mode, and you capture the swing in high speed. And then you take it back out as they're trotting off to first base. And then you can play it back, and you're not going to have any of the image degradation from having each of the frames be much shorter exposure.
So you're doing video, and can you apply all these focusing effects on each frame of video? What if you want to change the focus on, and you have many frames?
So yeah, so actually, right now, editing video is very difficult, right? Because you have to do it on every frame, and there's not a lot of automation involved in that. Because we can isolate all of the objects in a very high resolution, you can actually track right through the video. You can trace things through the video. And also, you can start to do some very interesting things relative to someone being occluded in the video and then coming back in. So you're watching, again, you're watching your kids play soccer, and they run behind someone. All right, now if you're focusing on them, you've lost them. Right? And then they come back out. Well, because you know where they were at the depth point when they come back out, you know where to look for them. Or you want to take a picture of them running up to the goal, right? With a legacy camera, you want to get them on one side and you want to get the goal on the other, and you do that, and the next thing you know, you're focusing on the lady across the field. Now you can select that person and you can track them in three-dimensional space. No matter where they move, you can keep them in focus. So that you can move the camera, you don't have to hold them in the center of the scene. So you get a much richer engagement with what's actually happening in the scene.
What about other kinds of applications for this technology? For example, medical imaging. X-rays today are kind of flat, not too much depth. They have devices which spin around the body and make little planes that a computer kind of assembles into a 3D form, kind of clunky to say the least. Does this have an application in that type of realm?